The second Hooghly Bridge is the longest cable-stayed bridge in India. This was constructed between July 1979 to October 1992. Also known as the Vidyasagar Setu, it is built using 4 steel pylons of height 122 meters each, with 152 cables in fan arrangement, such that each pylon supports the deck with 38 parallel wire cables, with one end at pylon head and the other at anchor at deck level. These stay cables consist of 122 to 277 high-tension wires of 7 mm diameter each, covered by high-density polyethylene HDPE duct of diameter varying from 140 mm to 200 mm. The bridge has 823 meters long composite steel reinforced concrete deck, which is 35 meters wide and 3 lanes carriageway in each direction and a 2.5 meters wide footpath on each side to resist uplift at the bearing. 16 holding down cables, each 30 meters long, are placed in 4 well shafts at the end of the anchor span. There are 2 expansion joints on each of the both ends of the bridge. The bridge being more than 25 years old, its various components such as cables, bearings, etc. need thorough maintenance, as a part of which HRBC engaged primary consultant Schleich Bergermann and Partners, Germany. Defects are found in cables such as damage in cable anchorage, severe car crash damage, bending and leakage in the cable duct of the holding down cable, corrosion in the anchorage socket and cable anchorage caps. Elastomeric bearings show complete damage. Pot PTFE bearings show squeezing out of the PTFE pad and breaking off pad chamber. The damage in the well foundation show unfinished joint between well cap and well and accumulated water in bottom pocket. Some places of the superstructure of the bridge has been severely corroded. The concrete in concrete deck has been subjected to spalling. There is also honeycombing in the concrete deck. Besides the damage, loose or missing bolts in the pylon.
We engaged RITES India for taking up as project procurement and management consultancy for the repair and maintenance works with design and other related aspects.
Before being replaced, the stay cables will be tested with electromagnetic and ultrasonic inspection along with tension measurement, while the new stay cables would undergo fatigue test and water tightness tests in different countries like France, Germany or USA before being approved for use. The rest of the stay cables will be tested to analyze load condition in different zones. Ultrasonic testing of all pylons will be carried out for its thickness and flaw detection of welds. Non-destructive tests like rebound hammer test, ultrasonic pulse velocity test and cover meter test shall be carried out on the concrete structures. Underwater investigation using remotely operated vehicles or ROVs, also called the underwater robots, with monitoring through CCTV at the control room shall be carried out for inspection of the condition of the underwater wells. RITES shall also establish actual control points to measure settlement of well, deflection or vibration in girder, displacement or tilting or verticality of pylons. Continuous structural analysis and monitoring will go on throughout the cable replacement period at all stages. Temporary cables will be installed to limit overstressing in adjacent cables and to support the bridge during replacement. The detensioning and removal of old cables will be done in 2 steps. In the first step, the cables will be cut, the cut cable being held with jacks. In the second step, the force will be progressively released by cutting the tensile elements one by one. The old cables had parallel wire system or PWS, which means that the wires were grouted with cement within the cable, whereas the new cables have parallel strand system or PSS, meaning the individual strands can be replaced if necessary. These cables will have inbuilt sensor for measuring load and vibrations and vibration dampeners. The outer cover of the new stay cables will be provided with light grey safety color coats for their lifetime of 100 years or more. Adequate outer spiral casing surfacing will be provided for the aerodynamic requirements. Anti-vandalism tube up to a height of 3 meters will be provided on all for prevention of damage due to fire to the cables. Fire safety coating on the cables up to 10 meters will be provided. All vertical as well as horizontal bearings are going to be replaced. In order to replace the vertical bearings, the hydraulic jacks will be fitted and the girders will be lifted. The slack or tension in the cables shall be adjusted after removing the old grouting and pot PTFE bearing with life of 25 years, pot UHM WPE bearing with life of 50 years and half the size will be placed with new fast setting grouting. The jack will then be removed. And the cables will be readjusted. For the replacement of the horizontal bearing, the grouting will be removed, after which the bearing will be replaced with disc bearing and then regrouted. Both bearings will have inbuilt load cells for measuring the load coming on the bearing. To monitor the structure after the replacement of the cable and bearing, 12 electromagnetic or EM sensors in new cables, 30 cables accelerated sensors in existing cables, 30 load cells or pressure sensors for measurement of load in bearings, 2 temperature sensors, 1 air temperature and humidity sensor and 1 ultrasonic anemometer shall be installed. To ensure minimum disruption of the traffic, smooth movement of the bridge components and safety and comfort of public and workers, a single lane of 4-meter width on both sides of the carriageways for the entire length of the bridge will be closed to traffic for the working space requirement for cable replacement. Remaining 4 lanes will be available for movement of traffic. However, during bearing replacement, complete traffic block for 12 to 18 hours on available Sundays will be taken for approximate 16 Sundays. No traffic block will be required for activities like pylon repair, well structure repair or girder repair. In order to ensure safety during the entire operation, elevators with stages shall be built for all high-altitude activities and speedboats shall remain commissioned 24 hours from day 1. Safety inspectors will be available on site.
I'm sure that this work will act as the reference work for any such future work undertaken in India. Thank you.
This one-of-a-kind operation is being undertaken for the first time in India. Technical archiving and documentation for this bridge can be referred to in the future projects. The health monitoring system being provided for this bridge may be replicated in the existing bridges which do not have such systems. Not only the technical aspect, but after repairs and replacement are completed, the aesthetics of the bridge will be positively enhanced as well, turning this structure into a statement of pride and joy for the city of Kolkata and our country.